Characteristics 2 and 3. How do we tell if something has a horizontal asymptote or an oblique asymptote? And what they're really looking at is what happens when our x values get really, really big. So in this first example, we have -4 over x plus 4. And we are going to apply that shorter sort of shortcut technique that I showed you earlier. That you can figure out all of these by just looking at the biggest degree in the entire rational function. So if I look at -4 over x plus 4, what's the highest degree of x that appears in this equation? It's just an x to the 1, right? A degree of 1. How many of those do we have on the bottom? We have a single x. How many x's do we have on the top? None. So we can say 0 x's on the top. If you simplify that, 0x over x, what does that simplify to? 0. And so this tells us that we are going to have a horizontal asymptote at y equals 0. We do not need to go into anything further than that. Now, the technique in the textbook, what they're saying is that if you imagine x getting very, very big, -4 divided by 1,000,000,000 plus 4, can you see that that answer gets really, really close to 0? That's the idea that they're using. But we're going to use our shortcut technique because it makes it a lot easier. We can skip over some of the synthetic division that they use. Here's our second example. What's the highest degree of x? X to the 1. So we have 1x on the bottom, 2 x's on the top. What does this simplify to? 2. Any time it simplifies, you'll have a horizontal asymptote at that value. Our third example here, x squared over x plus 1. What's our highest degree? X squared. We have 1x squared on the top, no x squareds on the bottom. What happens when you have x squared divided by 0? It's not possible. Any time that it's not possible, we will have an oblique asymptote, unless there was a hole that we missed earlier. But if it's been simplified and the holes have been taken out, and you still have the highest degree causing you to divide by 0, you're going to have an oblique asymptote. To find the equation of the oblique asymptote is a little bit more complicated. We have to use our synthetic division. You actually take your original equation, which is x squared, and divide it by x plus 1. So if I took x squared, does it make sense that I'd have 1x squared, I have 0 x's, and I have 0 for my constant? And if I'm dividing by x plus 1 in synthetic division, I would put a -1 out front. What are the steps for synthetic division? Bring down the number, multiply, add, multiply, add. What does this mean? This means x minus 1, remainder 1. After you've done your synthetic division, you can ignore the remainder. The equation of your oblique asymptote will just be this part. Even if the remainder was like 85,000 million, billion, trillion, whatever. Doesn't matter what number that remainder is. Your equation of your oblique asymptote will just be y equals x minus 1 in this case. Okay, so with that as an idea, we can now look at example 2 here. Before we decide if anything has oblique asymptotes or horizontal asymptotes, we're going to follow the same steps that we did in example 1, because we're preparing ourselves to be able to graph these by hand. So we'll always start by factoring our equation completely. Does the top factor? If it did, it would be x and x, 7 and 1, plus 7 minus 1. Yes, it works. So our non-permissible value, the first step we will always look at is our non-permissible values. x can't equal -2. Our non-permissible values are either holes or vertical asymptotes. What is it in this case? It is a vertical asymptote at x equals 2. Good. The second thing we will look at is our horizontal and or oblique asymptotes. We do that by looking at the highest degree in our equation. In this case, it's x squared. So we have an x squared on the top, and we have no x squareds on the bottom. That is not possible. You're dividing by 0. And since it's not possible, we are going to have an oblique asymptote. To find our equation of our oblique asymptote, we will use synthetic division. So we are taking x squared plus 6x minus 7. We're dividing it by x plus 2, so we put a -2 out front. Bring down the 1, multiply, add, multiply. So this means x plus 4 remainder of -15. Our equation of our oblique asymptote will just be the x plus 4. We don't have to worry about the remainder. Once you have all of your vertical, horizontal, and oblique asymptotes and holes figured out, you can start to graph. So what do we know? We know that we are going to have a vertical asymptote at x equals -2. So we can draw that in. We also know that we are going to have an oblique asymptote at y equals x plus 4. So that's a straight line. You're going to have 4 as a y-intercept and a slope of 1. And we can label that asymptote as well. Once you have all of your asymptotes, now it's a matter of putting some points. Again, we'll start with our x-intercepts and y-intercepts. If you plug in 0 for x into your original equation, can you see that you'll get -7 over 2? -7 over 2 will be right there. If you want to find your x-intercepts, well, that would be making our fraction, our y value equal to 0. The only place that a fraction is equal to 0 is if your numerator is equal to 0. So our x-intercepts are going to be at 1 and -7. Every time you have vertical asymptotes, they split your graph into sections. We only have one vertical asymptote. One vertical asymptote will separate it into 2 sections. Currently, we have points in both of those sections. Once you have points in both of those sections, usually you'll be able to just graph it. And that's the case here. If I have those points, I can graph, and I just need to make my graphs approach the asymptotes. So what will that look like? Ooh, that's a little curvy in there. It's going to approach my oblique asymptote, and it's going to approach my vertical asymptote. Same thing here. It's going to curve up like that and curve here. If these extended further, your graph would approach those. And so we graph our asymptotes. We find our x-intercepts and y-intercepts. Once we have those points, usually we get close to graphing. We might have to plug in a couple of new values to find new equations. Any questions about A before I erase it so that we can do B? Okay, part B. B is the same thing, just flipped. So the nice thing is for factoring, we already know that this is x plus 7, x minus 1. Now our non-permissible values. X can't equal negative 7 and x can't equal 1. Vertical asymptotes are holes. They're going to be both vertical asymptotes. You'll have a vertical asymptote at x equals negative 7 and one at x equals positive 1. After finding our vertical asymptotes or holes, the second thing that we will do is find out whether or not we have horizontal asymptotes or oblique asymptotes. What's the highest degree? An x squared. We have one x squared on the bottom and no x squareds on the top. 0 over x squared simplifies to 0. So we will have a horizontal asymptote at y equals 0. So now we can go to our graph. We can label all of our asymptotes. X equals 1, x equals negative 7, and y equals 0. We can find our y-intercept. Go back to our original equation. Plug in 0 for x. Can you see that you'll get 2 over negative 7? Do we have any x-intercepts? How do we know if there's an x-intercept? Well, we look at our fraction and we look at our numerator. Can that ever equal 0? This is weird because what happens is we have an x-intercept. Whoa, that's yellow. We have an x-intercept at negative 2 comma 0, even though we have an asymptote at 0. Okay? So whereas vertical asymptotes represent non-permissible values, and your graphs will never go through vertical asymptotes, horizontal asymptotes represent what happens when x becomes really big, either as a positive number or a really large negative number. They're not so concerned about what happens in the middle. They're concerned about what happens when x gets really, really big in either extreme, positive or negative. So it is possible that a graph can go through a horizontal asymptote in the middle. And that's what happens in our case here. So after graphing our x-intercept and our y-intercept, the only thing that we know so far, these are going to be connected and this has to go down. Because if it would go up, we would introduce another x-intercept. And we found the only x-intercept is x equals negative 2. with that, now we have to figure out some other stuff. We don't know from this point whether this graph in the middle goes down towards this asymptote or goes up towards that asymptote. The only way we could figure that out is if we add another point. So let's say we plug in -3 into our equation. Let's go up to our equation. Do you see that if I plug in -3 in the top, I'm going to get a -1. And on the bottom, I'm going to get 4 times a -4. So this equals 1 over 16. Whoops. Oh my goodness, now I've got to really hurry. Okay. So we get 1 over 16. Let's not watch that disappear again. We can graph that point. So we have, at -3, 1 over 16. And since that's a positive number, it has to go up. It can't go down, because if it goes down after that, it would introduce another x-intercept. And we only have the one x-intercept. I talked about in the last example how our vertical asymptotes separate our equation into different sections. Can you see that with 2 vertical asymptotes, we have 3 sections, and we still don't know what's happening in the first one or the third one. We just figured out what happens in the middle. So again, in order to figure out what happens in each of those sections, we plug in a number and see what happens. So let's try -8. If I plug in -8 on the top, you see I get -6 over -1 times -9, which comes out to -6 over 9. Perfect. Quickly scroll down, and we can label this point. Where would that be? That would be about here, -8 comma -6 over 9. You could reduce that to -2/3 if you want. But now that we have that point, we know there's no more x-intercepts. The only thing that's possible in this section is for our graph to look like this. And finally, we have to figure out something in the third section here. Let's plug in 2. If we plug in 2 to the top, we'll get 4. In the bottom, we'll get 9 times 1. That will be 4 over 9. Perfect. And so down here, I have the point 2 comma 4 over 9. And so in that section, it has to look like this. Okay, questions that we can do for practice. 6 and 7. So I'd like you to practice questions 5, 6, and 7, even though when you read the question, it just says, write the coordinates of the hole, write the equations. I want you to try to graph them all as best as you can for all of them. So I want you to go through the steps, find all of the equations of the asymptotes, find all the holes, and graph it as best as you can.